Hello and welcome to Vodcast 15.6. In this podcast, I will lead you on a tour of the terrestrial planets. The innermost planet, or the first rock from the Sun, is Mercury. Mercury is the smallest of the planets in our solar system, and what's really cool about Mercury is that a day is longer than a year on this planet. I know that probably sounds nonsensical, because here on Earth there are 365 days in a year. But Mercury revolves around the Sun quickly. It only takes 88 days for Mercury to make one full revolution. But it rotates very slowly on its axis. One day-night cycle on Mercury lasts 176 Earth days. Now, as a consequence of how slowly Mercury rotates, it has the greatest temperature extremes in our solar system. It can get as hot as 800 degrees Fahrenheit, which is hot enough to melt tin. But it can also get as cold as negative 280 degrees Fahrenheit. So this is a really morbid thought, but if you were standing on the border between day and night on the planet Mercury, with one of your hands held in the daylight and the other hand held in darkness, one side of you would begin to rapidly melt, and the other side of you would be frozen solid in a very short amount of time. The planet Mercury resembles Earth's moon in a variety of ways. It has very low reflectivity. In fact, only 6% of the solar energy that hits it gets bounced back into space. Mercury also has no sustained atmosphere, it has numerous volcanic features, and it has a very heavily cratered terrain as a result of having no atmosphere. The next planet that we'll take a look at is Venus. If we ever had to pinpoint the actual location of hell, Venus would probably be a good place to start. Due to the greenhouse effect, Venus is the hottest planet in our solar system. In fact, the average surface temperature here is close to 900 degrees Fahrenheit. On Venus, just like on Mercury, a day is longer than a year. It takes Venus 225 Earth days to orbit the Sun, but one Venus day lasts 243 Earth days. Speaking of Venus's rotation, it rotates in the opposite direction of all the other planets. This is a type of retrograde motion that Venus exhibits. What's really fascinating about Venus is that size-wise and composition-wise, it's very similar to Earth. In fact, in many regards, you could say Venus is Earth's twin, but you could not survive on Venus's surface. Assuming you could visit Venus and stand on the surface for even just a moment, the surface gravity there would be very similar to what you're used to here on Earth. But standing on the surface, you would be simultaneously burned, corroded by acid, and crushed. Because Venus has extraordinarily high surface temperatures, it has a corrosive acidic atmosphere, and the atmospheric pressure on Venus is extremely high. In fact, Venus has the densest atmosphere of all of the terrestrial planets. It's 97% carbon dioxide, and that's what accounts for Venus's really high temperatures. When we talk about the greenhouse effect occurring on Earth due to climate change, Venus is a great example of what can happen if the greenhouse effect snowballs out of control. We can't see Venus's surface directly because it's hidden by a thick cloud of sulfuric acid droplets, but we've been able to map the surface of Venus using radar, and the Russians have sent some probes there that have collected some very important data. Venus has over 1,000 large volcanoes, but because of the really high atmospheric pressure, the volcanoes on Venus don't build up vertically like they can here on Earth. Their volcanoes tend to be very broad, flat mounds, and the lava there can flow extremely far because of how hot it is. Put simply, the lava doesn't cool very fast when the temperatures are 900 degrees Fahrenheit. The final planet that we'll consider in this podcast is Mars, and Mars is the fourth planet from the Sun, with Earth being the third. It's important to note that Mars has the largest volcano in our solar system. Olympus Mons is 3 times the size of Mount Everest. In fact, if you want to fit this one single volcano in the United States, it would take up an area comparable in size to the state of Arizona. Mars has roughly half the diameter of Earth, and it takes 687 Earth days for Mars to revolve around the Sun. Surface temperatures on Mars can range from negative 140 degrees Celsius at the poles in the winter months to highs of about 20 degrees Celsius at the equator in the summer months. And 20 degrees Celsius is about 70 degrees Fahrenheit. So in the summer months at the equator, that temperature seems quite comfortable. But it's important to note that even with those really cold temperatures on Mars, the atmosphere is extremely thin, so it wouldn't feel like that biting cold that we have here on Earth. But going back to the really thin atmosphere on Mars, It's 1% as dense as Earth's atmosphere. The composition of Mars' atmosphere is 95% carbon dioxide, and there are small amounts of nitrogen, oxygen, and water vapor in Mars' atmosphere as well. Here's some additional information about Mars, and I've also included the picture of Olympus Mons superimposed over the state of Arizona to help you get a visual understanding of what I was talking about. About 2/3 of Mars' surface is cratered highlands. If Mars had abundant water, which we think it did long ago, it would flow north on the planet away from the highlands and form an ocean. Here's an artist's rendering of what an ocean on Mars may have looked like long ago, assuming there was one. Now, whether or not Mars had an ocean at one time is one thing, but we have pretty undeniable proof that water did flow across the Martian surface in the past, because we see evidence of dried stream beds. Shown at the far right side of this slide is what appears to be a dried up stream bed, and this looks very similar to the stream channels that we see here on Earth. Now, very obviously there's not water flowing through this channel now, but we do know that Mars has salty liquid water underneath its surface. And it's also important to note that Mars is known as the red planet, and the reason it's red is because of the presence of iron oxide. In your everyday life, you're probably most familiar with iron oxide as rust. Well, rusting doesn't occur without the presence of water. So the iron oxide that we see on Mars' surface, the substance that gives it its characteristic red color, almost certainly had to form in the presence of water. As I've already mentioned, Mars has some of the largest volcanoes in the solar system, but without the presence of flowing water currently, the dominant force of erosion on Mars is wind. Mars can experience very intense dust storms, and the winds can be as strong as 170 miles per hour for weeks at a time. Just like here on Earth, Mars has polar ice caps. And atop those layers of frozen water, we find thin layers of carbon dioxide snow. Think about that for a second. It can snow carbon dioxide on this planet due to its extremely cold temperatures. Okay, that concludes this Vodcast. Hopefully by looking at these 3 planets, you can see how diverse and special our solar system really is. But we're not done yet, because in the next Vodcast, we will tour the Jovian planets.